and welcome to this new tutorial on Emgu CV. Today I'm going to explain how we can use the color transformations in Emgu CV. There are more than hundreds of color transformations supported by OpenCV, but these are the most commonly color transformations which are used. So I'll be going to explain how we can transform between BGR and these color spaces, but the overall idea is same for other color transformations as well. So let's get started. I have already created a project and it is configured to use Open Emgu CV. If you don't know how to configure it, please watch my one of previous videos about Emgu CV configuration. Let me add a Windows Forms. Right click on your project, go to Add, go to New Item. This will display a Add New Item dialog. Select the Windows Forms and give it an appropriate name. I'll just keep as it is. So click on Add, and this will add a new forms to the project. What I will do is use a strip menu and then select the appropriate transformations and apply them on the images. So let me drag and drop a menu item, and also we need some picture boxes. So go to Common Controls. Here you can see picture box. I need two picture boxes. One is for the displaying the input image, and similarly Control C, Control P. This one is for the output image. In the menu item, I will write File and add an Open to open an image, and optionally you can say an Exit as well. And in the image transformations, let me say that this is color transformation. I want to do few color transformations as I have shown in this slide. So let me write BGR. I'm assuming that my input image is BGR. This is for gray color, BGR to YCRC B color space, then BGR to HSV color space. This menu will be for BGR to LUV, again BGR to this menu wavy for lab color, and then lastly BGR to HLS. So let me implement the open method. Double click on open, and as usual what we first need to do is to instead of repeating it again, write this one open EmguCV.cv namespace, and also EmguCV.structures. This basically defines the data structures. And also I want to create a global variable for this class. We can say a class scoped variable. It is just to contain the input image BGR. I call it Emgu input. So when I click on open, this event will be fired, and I want to read that image. If before that, open file dialog, or file dialog is equal to new dialog, and I just want to display this dialog for the user first. Dot show dialog. This will show the dialog, and if he clicks on an image and he clicks OK, then it means he has selected an image, and then I will read it into this Emgu input. So I'll say Emgu input equals new Emgu input, and open file dialog dot file name, the file which the user has selected. And I want to display it in picture box 1.image equals to Emgu input dot bitmap. Next thing, the exit is simple. Let me show you. For example, I just want to close this application. This object dot close. This object means this form. This for, as we can see, we are inside this form 4 class. And the first thing that I want to do is when I click on this, I want to convert the input image, which is in BGR, I assume, and convert it into grayscale image and display it in picture box 2. So let's go and double click on this. The first thing that I just want to make sure that Emgu input is not null, that is some image has been already read. If it equals null, I can show a simple message to the user. If you say mbox, you can see, and double tap, this will automatically write the code for you, and we can send a message, please select an image. Okay, and then return. What I want to do, if the input image is null, of course we cannot do any further processing. That's why I displayed a message and return. So no further code will be executed, rather this will be returning back from this event. So if it is not null, then we can convert it into grayscale image. So the first thing I want is to create a variable whose color is gray and depth is the same as byte, and I call it output. I should say image output equals new image output. Just what I want to do here is the size of the image will be same. So Emgu input dot width, Emgu input dot height, and maybe optionally you can initialize it with some gray values. I say let me initialize it with 0, so it will be a binary or a grayscale image whose values are set to 0 initially. And there are two ways in which we can actually do a color conversion. The first and the simplest one is, I would say Emgu output equals Emgu input, which I want to convert into grayscale. I use the function convert, and here I can pass the value in which color space I want to convert. Of course I am going to convert it into grayscale, and this is done. So simple. And we can show it in picture box 2.image equals Emgu output. And of course we need to convert it into the bitmap. So this is the property, bitmap property, so that the image requires an image of bitmap. The first thing that you need, since I am developing this project with an existing one, and I want to launch this form 4 first, so I need to make sure that in program the object that I want to create is not for form 3. I want to show form 4. It is in programs. So application.run, I passed the object of form 2 over here. So just to make sure. In your case, if you are creating the project and if it is the first form, there is no need to change it. However, you just need to make sure that this is the desired form. That's it. Let me run it and check if everything is going fine so far. So let me open an image. Let me select Lena and convert into grayscale. So it is working fine so far. So let's check the other method which can be used for image conversion. This is relatively easy. And the second method that we can use for image conversion is we can call CV invoke.convertColor. And here what we need to do, we need to mention the source image, that is Img input. We want to mention the output image, Img output, and here is the color code that we can select. There are more than 139 color codes available for different conversions. So emguCV.cv.cv.enum.color conversion. Here are, you can see all of the supported enums which you can use. At the moment I want this BGR to gray. That's it. And I will comment on this one. I created the object and then used the CVT color, that is convert color method of CV invoke, and passed the source image, the destination image, and we need to select what actually we want to do. So I selected this enum of BGR to gray, means I am going to convert the BGR image into a grayscale image, so that, and then I displayed the same thing in the image box too. Let me run this and check it again if we get the same output or not. Color transformation, grayscale, so that's it. So these two methods, I usually find this one very simple, and this is also the method that is available for different color conversions. Let's get ahead and implement the same concept for YCRCB. Double click on that, and in this case what I will do, instead of writing the code again, I'll use the magic of copy and paste. Here, since I'm converting into not into a gray image, so we have a structure that is called YCC, and you have to also say that I want to convert into YCC. That's why we created an object. Now the image Img output is of type YCC, and the color depth is byte. So let me remove this. I don't need to initialize, and I don't want to initialize it. And here you need to change this into YCRCB. And here's something interesting. All others are same, the image output is same, and now this one is, instead of gray, now I have YCC image. Let me run it and check. Open a Lena image color. Now what happened? It did not change the color, or it did not perform the color transformation. Or is it? Actually it did, but it displayed it in a different way. What I want to emphasize here is, now look at this. What we have done, actually this Img output is basically type of YCC, but since we use this bitmap property, so what it checked inside is that it checked that this is a YCC image. It converted back into the RGB space, and then it displayed as it is. To confirm this, let's see if it shows. Let me show this in show, yes, and let's say this is YCC, and I'm going to Img out. Let's see what this ImShow is going to show us. It is not going to convert it back into RGB image, I'm sure. So let me hit BGR2. So that's it. What actually, the image has been converted into YCRCB color space, but since we use this property, as you can see, when it finds that this is a YCC image, so it converted it back into RGB to display it in image box. So how can we do that? Actually the data is in YCC, but just to show it, it is converting back into RCC. We can use a simple you can say a shortcut way of doing that. Let me delete this. What I will do, actually is I will copy this one and paste it over here, and I call it image final output. This is a gray image. What I want to do, once we convert this image into YCC color space, I want to assign the same data into Emgu final output, so that the image, this bitmap property will not change back into RGB, rather it will display as it is. So what I'm going to do here is, it's very, you can say it is a shortcut for dealing with this. Dot data equals to Emgu output dot data, and I want to display this Emgu output dot bitmap, so that it will, for this bitmap, it is actually a grayscale image, so it will not do any transformations back into BGR space. File, open, Lena, open, and now, oops, what happened? The destination array was no, oh, let me see. This is, you can see, by 225 228 by 1, and this one, oh, 228 225 to, it's a 3 channel image, so I made a mistake here. This one should be BGR, not gray image, so let me create a BGR image, and of course here I don't need to provide it. Let me delete this, and let's run that. File, open, select image, okay. So here you go. So similar to this thing, I can copy this, apply for this one, and instead of YCC, just what I need to do here is select the HSV. Here also we need to change HSV, and since we are converted into HSV, so I will select the HSV here as well. So this is done for the other one. Similarly, LUV space, I just need to convert into LUV. Here also LUV, and which one? This one, LUV, and it looks a repetition of the same work, and actually it is. and in lab color space, and also over here lab, and lastly HLS. I want to do it into, sorry, HLS. Okay, here also HLS, and also here we need to pass into HLS. Let's run this and check if it works for us or not. Open an image, call it Lena, okay, select gray, great, YCRCV, HSV, LUV, lab, and finally HLS. So the why we are doing the color transformation, sometimes we need to do it depending on what kind of application we are working, and maybe in the next video I'll show how we can use skin color detection using HSV color space. I hope you enjoyed the video and hope to see you in the next video.